Hi, everybody. I'm going to give a quick background on what is 3D printing and why it's important before getting into some more details, and then pass things off to Skill Mill NYC, who's going to talk further about more in-depth how you actually go about modeling and 3D printing your designs. So for anybody who doesn't know 3D Hubs, it's a company that was founded in 2013. It's based in the Netherlands, and it's a web-based platform that allows people who don't have access to 3D printing technology to easily find it locally. So it's a network of 3D printers, and in the last 3 years, it's grown to now include close to, I think it's as of today, close to 40,000 printers around the world. It's in more countries in the world than McDonald's has locations. What is 3D printing? Why is 3D printing important? 3D printing, in contrast to other methods of manufacturing, is different because it can be really local. You don't have to travel to some large facility or send your design somewhere and then have it shipped to you. You can find 3D printers often within a mile radius of you, especially in the city. Globally, on average, 3D Hubs calculates based on their hubs and population density that over 1 billion people on the Earth are now within 10-mile radius of a 3D printer. So that is a new thing for us as a world, which is very exciting. 3D printing also is on demand, so instead of ordering a large amount of something or to meet some minimum quota, you can just get as many of whatever thing you need made. So it reduces waste, and it's also customizable, easily personalizable. So if you want to make small changes, that's easy to do, in contrast to other methods of manufacturing, such as injection molding. So there's a lot of really distinct benefits that 3D printing affords you. So the printer I have over there, which some of you may hear making cute robot sounds as I present, is an FDM machine. FDM is an annoying acronym of which there are many to refer to different types of 3D printing. It stands for Fused Deposition Modeling, which is a fancy way of saying it's basically a hot glue gun that's squirting out plastic and being moved around with varying levels of precision. So this diagram we have here is showing you the spool of plastic. Actually, because some of these animations in these slides might not work, I brought a laser pointer to help us see what's going on here. So 3D printing, there's a spool of plastic, sort of like a spool of thread, feeding plastic into the nozzle that gets really hot, and then it's just printing whatever model you have layer by layer on a platform that's slowly just moving downwards, the X, Y, and Z axes here. That's the gist of it. And from that, there's been an explosion of different forms on this. So FDM is one of the ones available, and there's also SLA, DMLS, LBJ. That's not actually one of them. There's many different acronyms of types of 3D printing technologies out there that all are based on the same basic idea of taking a model, slicing it into layers, and then creating those layers one on top of the other. So with what 3D Hubs allows you to do is you can take whatever design you have, some blueprint, some nugget of data, you upload that to 3D Hubs, and then select the type of 3D printing technology that applies best to your needs. So FDM can really easily do plastic parts, but it's also possible to print in solid metal or transparent acrylic. So depending on what you need, you select the type of service, and then it'll show you, based on your location, what different hubs are available that can handle the job you have. And the nice thing about 3D hubs is there's a broad range of machines on there. There's small desktop machines like the Formlabs desktop SLA printer, all the way up to $250,000 car-sized machines that do really high precision work. Both of these things are available through 3D hubs, all just depending on what your end goal is. So yes, as I previously stated, 3D hubs is the largest network of 3D printing services, and it's sort of following in the style of Spotify, Netflix, and Amazon Kindle. What Spotify did for music and Netflix did for movies and TV, Amazon Kindle did for books, 3D hubs aims to do for manufactured objects. So what's coming up in 3D printing? What's there to be excited about? Here's another breakdown of technology. This we will have to collectively imagine as a video because, once again, Keynote, not backwards compatible. So it's not actually moving at 7 times the speed. It's a static image. But this is the carbon 3D printer, which is a new type of SLA printer that can print very, very quickly at really high levels of accuracy. So imagine together this moving up layer by layer, layer by layer, creating a really interesting looking globe object here. These are relatively new machines, the carbon printer. They can be rented for, I think, $40,000 a year, something like that. But this technology, which is maybe only a little over a year old, is quickly becoming more and more accessible to more and more people, which is a very exciting trend to keep an eye on. This is a printer more in the style of the one that I have printing over in the corner. Although this image is the voxel printer, so not only does it have this heated nozzle extruding plastic, it's also able, through the same nozzle, to extrude conductive material, so you can print circuits into your objects. So rather than the old method of PCB design where you have a copper sheet where you cut traces and then use an acid wash to remove the parts you don't need, et cetera, there's now this new capability of, rather than sticking to 2-dimensional layers, you can print circuits in 3 dimensions. So you can have traces that change angle, not just in the 2D plane, but in 3 dimensions, which is opening up all sorts of new possibilities and potentially very exciting for anyone looking to integrate electronics and 3D printing together. This also, another beautiful video of 2 different material types, showing the different material properties that you can achieve through 3D printing, different types of elasticity. So this ball, we can imagine the hand dropping it. It's extremely bouncy. This one absorbs the impact much better. So even for like soft robotics applications or other types of toys, you can get very specific material properties through 3D printing, which previously were only really accessible to people who could afford to do injection molding and go through that entire prototyping process. So let's get into some more specifics about materials. The most common type of material that people use for 3D printing is called PLA. That's what I'm working with over there. It's a corn-based plastic. PLA stands for polylactic acid. It's nice because it's relatively cheap to manufacture. It warps very little, as in when it gets hot and cold, its volume doesn't change very much. So it's easy to work with. It has like a, as they say in the industry, dimensional stability. And it's also biodegradable, so you can toss it in a compost pile. And if you want some more strength from your objects, you can move on from PLA to plastics like ABS, or you can use laser sintering to harden beds of powder of any material you want, from plastics to metals. And Interestingly, there's also printers that can print not only with a strand of plastic, but inside that strand have a band of Kevlar or carbon fiber to add strength to what you're making. 3D Hubs last year launched another portion of their website, the HD portion. So you can specify that you want an HD print. And these are machines that are able to print in much higher resolutions than typically are achievable with FDM-style desktop machines. So for people who want to make professional prototypes or end-use products, an HD hub is a really great resource to use. Let's see, polyjet printing is another example of an HD type of printing. You can get really complex geometries. You can have enclosures that snap fit together in a really precise way, and you can also control the finish on the outside of the objects as you do with injection molding. SLS nylon, this is selective laser sintering. And so this is a great technology because you basically, the resolution is, you can get down the resolution down to the particle size of the powder you're using. So you are running a laser beam over a bed of powder, and then another layer of that powder is added on top of the one below it. And as fine as you can get your powder is the limit of the resolution you can achieve on these types of prints. So SLS and powdered nylon are a really good combination because it's very high definition and also has the strength of nylon plastic. What I'm printing over in the corner there is actually this design, a case for an Arduino Uno, which people who are involved in electronics may recognize that name. It's a really good small microcontroller, great for products. And along with this, you can see other very high accuracy prints and end-use products. This is highlighting, as I said earlier, fiber-reinforced plastic, which is increasingly becoming available. And this, another animation, is some of that fiber-reinforced plastic printed into a chain being tested. And as you can see, it snaps in the middle once it reaches 21,000 pounds of force. So that is strength on par with machined aluminum, but out of a 3D printer. So for the price of plastic, you can achieve the same strength as milled aluminum, which has never been accessible before. Very exciting. Aluminum strength to the place of plastic. It's almost as though it knew what I was going to say. So we have a couple use case studies of people that have used 3D Hubs to get their products off the ground. The first one is JewelBots, and this, incidentally, is a project that I worked on before I realized what it was. This design was sent to my hub a couple years ago, and I printed a couple of these prototypes, and then only a couple years later did I actually see that it had become a real-life project that you can go out and buy. So that's exciting as a personal example for me to realize that I was part of this successful entrepreneurial scheme, but also is neat to see that people are successfully launching products through 3D Hubs. This order that I received, I tried to look back through my orders and find it. I believe it was fairly inexpensive. It was around $20 for a couple different orders, a couple different iterations they tried. So in terms of the cost to get prototypes made, it's inexpensive at a level that has never been seen before. What JewelBots is a bracelet that introduces children to programming, to simple Arduino-based code, so they can program their JewelBots to communicate with other JewelBots, share them among friends, and send secret messages through series of buzzes or blinking lights, and locate each other or send secret messages. I'm not sure. I haven't used these. Here's some of the prototypes that I helped work on. This is a Ninja Flex print, something flexible and soft, and they tried some other hard FDM prints for the shells, and then this is, I believe, a Polyjet print in the end, before they moved on to having that injection molded out of silicone. Flirty, a drone delivery system, is another company based in New Zealand that's trying to get drone delivery off the ground. And so their prototyping process involves creating different housings for their drones that would protect the electronics inside and also house whatever arms they had that were carrying their cargo around. Ringly, you can get a sense, there's a pattern to the names here. Ringly Smart Jewelry, another product that was prototyped through 3D printing. This is now available. It's a ring that you can pair with your phone and receive buzzes or different color lights based on the messages you're receiving. And for something like this, something the size of jewelry, the prototyping costs are very small because prints like these take up very little space. And something the size of a ring usually will take between 5 to maybe 15 minutes to print. This is a more high-tech example. Nike and HP collaborated to work on a cooling hood for Olympic athletes. And so the idea here is that you could have a cooling pads that are housed inside this helmet, and then the way the helmet is constructed, it would allow the athlete's body to achieve thermal regulation much faster than it could naturally, which for athletes that are going through very quick bursts of performance can be really helpful in allowing them to recover a lot faster. These 3D printed headphones are another interesting example of where 3D printing was used not just for prototyping, but for the end product. So these headphones, which are customizable and you assemble yourself, the end product, the housing here is actually itself 3D printed. So 3D printing isn't necessarily stuck to prototyping, but you can create product level prints that can actually go out to consumers with it. The Go made-to-measure wheelchair is another interesting example. This is a wheelchair where the designer wanted to create a wheelchair that could really easily take a scan of someone's body and then create a wheelchair that was formed specifically for them, rather than just getting a one-size-fits-all wheelchair. And through 3D printing, there's also forms that aren't possible through other manufacturing techniques. So unfortunately, we don't have a full picture of this wheelchair. But if you care to look up the Go wheelchair later on, it's a really interesting and beautiful example of large-scale, high-accuracy 3D printing. So if anybody has some project that they're interested in working on, we're going to go through a couple of the ways that you can start getting that off the ground. If you have a design and you have some experience in 3D modeling, you can create it yourself. You can find someone who knows how to 3D model and explain to them your idea and have them make it for you. Or in a lot of cases, when I've thought of something that I want to 3D print, I will literally just go to Google, type in the name of that, say giraffe. If I want to like find a model of a giraffe, I'll go and write in giraffe and then just 3D after that. And then in a lot of cases, you can find some model that already exists. And depending on what your end goal is, you can modify already existing designs that you find online, or you can create something from scratch yourself. With 3D printing, as with any other type of manufacturing, there are some rules you have to follow in terms of wall thicknesses and overhangs. So this is important to keep in mind when you're designing something for 3D printing, but in a lot of cases, any shape, any complex geometry you have can be achieved through 3D printing. It's just with more or less difficulty. So layer thicknesses. For most printers that you'll encounter in the world, 1 micron is the thinnest layer height that you can achieve, which is about the thickness of a piece of paper. So it's pretty good, unless you need something better than that. Your best bet is just to stick with the 1 micron or 100 micron layer height. If you need something really large, though, there's also printers like this, the big rep. I've seen a couple of these printing in action. They can print something the size of a coffee table or a large chair. So 3D printing doesn't necessarily have to be stuck at the very small scale. It's possible to print very large objects. And these people decided they would print the mascot of 3D printing, Marvin. Marvin, for those who don't recognize him, is sort of a first test print that a lot of people do. If you get a printer and you want to make sure it works, you print Marvin, and it has some small features that are useful for diagnosing any issues your printer might have. There's some slight overhangs here in the eyes and in the hood, and you can really easily see based on the curvature around him how your layer heights look, and if there's any wobbling on any of the axes. This, unfortunately, is another breakdown of Keynote, but I will use the laser to demonstrate. You have a small model, and you can scale it to a larger model, is basically what we're getting at here. Scaling is important, especially considering that depending on what country you're in, be it Europe or the United States, you may be working in metric or in the imperial system. So oftentimes, when I'm receiving orders through 3D hubs, will have to convert from inches to millimeters in order to make sure that the print is at the right scale. It can be suspiciously confusing sometimes. If you do, however, have a print that is too large to fit within a print bed, let's say, for example, you have, work with me here, a couch or something with large cushions, and it really needs to be that size. It's possible to slice that up into different chunks and just print those blocks one by one, and then after the fact, reassemble that into the larger object. And I have done this with a couple larger prototypes, and it's actually pretty fun to create a 3D printed puzzle and then reassemble it after the fact. So people have demonstrated that it's possible to print in something the size of an elephant. Somebody printed a life-size elephant using a machine that size, just piece by piece, building up block by block until they had an entire elephant. So these things are possible, though it does take some time. Here we have our friend Marvin again, and hopefully you can see some of these, the differences in layer height. As you go from left to right, you're increasing in resolution. So we have over here a very thick layer height, maybe 500 microns, down to maybe 300 microns, to 100 microns, to maybe 15 microns over here. Not only is it important to get your object scale correctly, but know based on the resolution you're trying to achieve what layer height you're going to be looking for in 3D printing. And with this, you can achieve really highly detailed designs like this jet engine model, which is a very popular print on the internet. Depending on the geometry of your model, you may need to have support structures. This is the support structure that is automatically generated from an SLA type print, stereolithography. And so this is one where there's a resin bath and a laser or a UV projector is curing that resin layer by layer. And because of some of these complex overhangs, it needs to have a little bit of support here. The support structures used in FDM style printing, like the machine I have over there, look slightly different. But regardless, depending on the complexity of the model and how accurate you need some of the overhangs to come out, knowing that you'll need support structure and having a general idea of what that support structure is going to look like is important, because supports can add a lot of time to 3D prints and also make them more expensive because they're using up more plastic. So just a recap of 3D hubs here. Some of the benefits are that it's incredibly fast, on average about a 48-hour turnaround time. In a lot of cases, I can receive an order in the morning and then have that order delivered to the person who ordered it by that evening. So better than 24-hour turnaround times, although of course for complex models it sometimes takes longer to get those printed. But even better, if you just need to find out how much it would cost to get something made, you can get instant quotes, just upload your design, and it'll give you price breakdowns based on the materials and the different resolutions you're looking for. And there's free expertise. You don't necessarily need to have a model that you want to print. You can go just with a question and find somebody who works with the type of technology you're interested in using or the type of materials you want to use, and send them just an inquiry and get some professional level advice for no cost. So for anyone who's interested in getting a little deeper into 3D printing, these are all the resources available through 3D Hubs. Basic intro to 3D printing, the materials guide on the types of materials available, tips and tricks if you yourself are getting into 3D printing and want to get better at it. And then there's a general knowledge base that's available for anyone who's part of the 3D printing community. And with that, I'm going to hand things off to SkillMill. I will be available after this over by that printer. If you have any questions, feel free to come by and pester me. Otherwise, thank you everyone for your attention.